Okay, hi everyone. In this question, we actually have a worker who's pushing a box and across a surface that's not smooth, and we are given that there's a coefficient of kinetic friction of about 0.2. The box is actually moving at constant speed across that floor. Hence, they gave the kinetic friction coefficient instead of the static friction. Okay, so what we need to do is draw the free body diagram for this situation. So let me put it as y up as positive and x towards the right as positive. Okay, now let's look at the forces that's acting on the box. We have mg. Okay, since it's resting on the floor, we have normal force. The worker is pushing, so we have Fp. So let me label that as pushing force. And we know there is friction. Okay, yeah. So in this question, most of it is kinetic friction, so I'm actually going to put mu k, the coefficient as mu k. So let me just write the formulas just for completeness. So in y, what we have is the normal force plus negative mg, that equals to 0. So n therefore equals to mg. So in x, we actually have the pushing force minus the friction, plus the negative friction equals to, so in these cases there's constant velocity, so ma equals to 0. We also know that F friction equals to mu k times the normal force. Okay, so in the first question, it says what force must the worker apply to maintain the motion. So it means that we are actually needing to find Fp. So let me write A. So Fp will be equals to F friction equals to mu k times the normal force, and the normal force in this case is mg. So mu k is given as 0.2, mass is 11.2, and g is Earth's gravity. So that gives us a value of 2.2 newtons. Okay, second part of the question. Oh, so what happens in the second part if the pushing force is removed? So initially that box has a constant speed of 3.5. When you remove the pushing force, the box will then still start to move at its speed, but it will slow down. So what happens is we actually need to get the deceleration. So how do we actually get that? So we need to redraw the free body diagram a bit. So it's just removing the pushing force. So let me just draw it. So it's the same as before, just that normal force, mg, and then we just have F friction. So this is part B. Yeah? So then we actually need to equate the forces in y and in x again. So in y is the same as the initial, but in x here is slightly different. In x, so what happens is you actually have negative F friction. Okay, so that's the only force that is present, and it's accelerating or actually decelerating, so it will be equals to ma. So therefore the acceleration will be equals to F friction, which is going to be negative mu normal force mg over m. Okay, I can cancel out m. So the acceleration is just equals to negative g times mu. So it's negative 0.2 times 9.81. So that gives us a value of about negative 1.96 meters per second. Okay, so that is the deceleration that the box will experience. So means that from an initial velocity of 3.5 meters per second, it will then have a final velocity of 0. So the question is basically asking us how far the box travel. So in order for us to solve this, the best equation will be v final squared equals to V initial squared plus 2AS, or X final minus X initial. So if I have V final equal to 0, I can rearrange this formula to be S equals to negative V initial squared over 2A, or equals to negative 3.5 squared over 2 negative 1.96, and we get a value for the displacement or distance of 3.1 meters.